Hello, and this video is going to be on lesson 3-1, and this begins on page 29. So we're going to be focusing on how to use graphing, substitution, and elimination to solve system of linear equations and two variables. So in the previous lesson 2-2, we learned about how to graph a system of inequalities. So here's our system, and the inequalities that we came up with were 40m plus 100t is less than or equal to 1360. We also had that m was in between 6 and 14. Number of tickets has to be less than or equal to 10. And we also had that m is less than or equal to 2t. So here is our system of inequalities. And when we graphed this, basically the shaded area represented all the solutions. The shaded area and the solid lines that were a boundary of the shaded area. So that is what a system of linear inequalities look like. But what about a system of linear? So we have a system of linear equations. How is a system, the solution to a system of linear equations, going to look like? Alright, so let's go ahead and begin by graphing this. So remember, this is in y equals mx plus b. Here we have our y-intercept, which is 1, and our slope is going to be 1 over 1. So we go up 1, run 1, up 1, run 1, and the pattern is basically going to look like that. Okay, let's go ahead and graph this other one. Y equals negative x plus 4. My y-intercept is at 4. This time my slope is negative 1 over 1. So instead of rising 1, I'm going to go down 1, run over 1, down 1, run over 1. So when I connect those dots, and that is my graph right there. Alright, so let's compare a system of inequalities where the solution is the shaded area and the solid line boundaries. And here's a system of linear equations. Notice that a system of linear equations does not have any shaded area. So what does the solution look like then? Well, the solution is actually going to be the point at where the lines intersect. So right here at this point, that is the solution to the system of linear equations. So we graph this, but can we tell specifically where the coordinate of this point is going to be? Well, that's the limitations of graphing. How do I know what this exact point where the lines intersect is going to be? So what we need to do is, instead of relying on graphing, we need to learn about substitution and elimination. Okay, so here is a system of two linear equations with two variables. Alright, so the steps for substitution, the first step is going to be, here's my first equation, and here's my second equation. So what I'm going to do is solve the first equation for y. That is the first step. So I want to go ahead and take my y minus x equals 1, and all I have to do is just simply solve for y. So how do I solve for y? I just add x to both sides. So what that gives me is y is equal to 1 plus x. Okay, here's my new first equation. Now we're ready for step 2. Substitute y from your first equation into the second equation. So y is equal to 1 plus x. Y is equal to 1 plus x. So let me write down the second equation. Now, instead of writing y, I found out that y is equal to 1 plus x. So I'm going to write 1 plus x plus x equals 4. So the reason I put 1 plus x in parentheses is because this used to be y, but now I replaced it with 1 plus x. So we don't really need the parentheses. And now we have an equation where we can solve for x, because that is the only variable that I have. So let's go ahead and simplify this. We have 1, x plus x is going to be 2x equals 4. We subtract 1 from both sides, so we have 2x is equal to 4 minus 1, which is equal to 3. Okay, we go ahead and again we're going to divide by 2, and here we have x is equal to 3 over 2, or 1.5. Okay, so we found out what x is equal to. We solve for the first equation for y, and then we substitute y from the first equation into the second equation, and we get this answer. Now let's go ahead and take x equals 1.5. So we're ready for step 3. Step 3 is to substitute x into equation 1. Alright, so we're going to take equation 1, y minus x equals 1. This is my equation 1. And since I already know what x is equal to, instead of writing x, I'm going to write 1.5 is equal to 1. So now what we can do, substitute x into the first equation and solve for y. Okay, so we need to go ahead and add 1.5 to both sides, and what that gives us is y is equal to 2.5. Alright, there we go. And so we just use substitution in order to solve our system of linear equations, and so my ordered pair is going to be 1.5 and 2.5. Here's my ordered pair. Now this system is the same system that we just graphed here in the first example, and if I look at my ordered pair, which is 1.5, here's 1.5, and then 2.5, that gives me exactly the point of intersection of both lines. And so So as you can see, using substitution gives us that exact point, exact ordered pair where the intersection is going to be at. So substitution is definitely more precise than graphing. Alright. What about elimination? Well, this is another method that we can use in order to solve the system. Alright, so let's take a look at step 1. Now, to understand what we're doing in elimination, let's go ahead and take a look at this question. If I have the expression x and 5x, what do I multiply the x by so that when both expressions are added, it equals 0? So when I add these together, x plus 5x, that gives me 6x. Now, I need to multiply this x by something. I don't know what it is, but I want to multiply by something so that when I add them together, it gives me 0. Okay, so a very common guess that students would give me is that they would say 0. Multiply it by 0, and that's going to give you 0. Alright, so if I have 0x, well, that just basically becomes 0, plus 5x, that, when I add them together, that gives me 5x. So it actually doesn't give me 0. The correct answer here is to multiply by negative 5. If I multiply by negative 5, I get negative 5x plus 5x, which gives me 0. Okay, so how is this idea going to help me with substitution? Alright, well, let's go back. So again, let's concentrate on these two expressions right here. Now, when I add these two expressions together, I'm going to get 2y. Okay, so I don't want to get 2y. I want to get 0. So my first step that I want to do, here's my first equation, here's my second. First step is to multiply the second equation by a factor to eliminate y. Okay, so I need to multiply this second equation by a factor to eliminate y, and then add equation 1 plus equation 2. Alright. So when I add these together, I get 2y, but I want to get 0. So what do I multiply the second equation by? Well, again, students always tell me to multiply by 0, so if I multiply the second expression by 0, I get y plus 0, which still gives me y. I don't want that. I want to make these so when I add them together they give me 0. So basically, let me write the first equation, y equals negative minus x equals 1. What I'm going to do is multiply the whole second equation by negative 1. So in the example that I showed you, we have just expressions here. We multiply by negative 5, and that's all we have to do. When we're talking about equations, if we're multiplying y by negative 1, we have to multiply the whole equation. So what we get is y minus x equals 1. That's basically equation 1. And now equation 2 becomes minus y minus x equals negative 4. Alright. Now, when I add these together, that's going to give me 0, which is what I wanted. And then we have negative x minus x, that gives me negative 2x. And then we have 1 minus 3, which gives me negative 3. Okay, now we can go ahead and solve for x. So divide by negative 2, and then we get x equals 3 over 2. Alright, there we go. Alright, so we're gonna go ahead and go to step 2, which is basically, since we already solved for x, we're going to substitute x into the first equation. Actually, what the book says is to use the equation that you multiplied at the very beginning. So we actually multiplied the second equation, and so we need to plug x into the second equation. So the second equation was y plus x equals 4, and so what we need to do is go ahead and plug in 3 over 2, which is basically 1.5. Plug it in, y plus 1.5 equals 4. And this should look very familiar. We already did this before. And what we get is y is equal to 4 minus 1.5 is going to be 2.5. There we go. So my ordered pair is going to be 1.5 comma 2.5. Here it is. Is that the exact same answer we got from substitution? Yes, we did. There is the answer for substitution. Here is the answer for elimination right there. Okay. So maybe there wasn't much different, or maybe you might think that elimination seemed a little bit more complicated, because in the end we ended up substituting x into the second equation. So what we need to do, you can definitely get I definitely had you guys work some more examples from lesson 3-1. So we had A, B, C, and then you solve these using substitution, and then you try these A, B, C using elimination. But basically the real difference, we really start seeing the real difference between substitution and elimination is when we start looking at solving systems of 3 linear equations in 3 variables using substitution and elimination. So let's take a look at a system of 3 linear equations with 3 variables using substitution. Okay, so the basic idea that we followed in the previous example is going to be the same. So in the previous example, we took, for substitution, we had to solve the first equation for y. We're doing the same thing here. So because we have 3 variables, we're not going to solve the first equation for y, but instead we're going to solve the first equation for z. So step 1, solve equation 1. So this is equation 1, and then 2, 3. Solve equation 1 for z. Okay, so let's go ahead and take equation 1, and basically in order to solve for z, well, let me go ahead and write it out. 2x plus 7y plus z equals negative 53. So when I go ahead and solve for z, what I do here is subtract 2x, subtract 7y to the other side, and z, this all goes to 0, so z is equal to negative 53 minus 2x minus 7y. Okay, so this becomes our new equation 1 right here. Alright, second step, substitute z from equation 1 into equation 2. So here's equation 2. I'm going to go ahead and write that out. So I have negative 2x plus 3y plus z. Now I figured out that z is equal to this, so that's what I'm going to plug in. Instead of writing just z, I'm going to write negative 53 minus 2x minus 7y. And then I'm going to write the rest of the equation, which is equal to negative 13. So as you can see, instead of writing z, I wrote what it's equal to. And this is basically still the second equation. So what I want to do now is just go ahead and simplify. Now we don't need this plus here. It's just telling me that I'm basically subtracting 53 right there. So I have 2x right there, minus 2x, and minus 2x. Combine like terms, that's going to give me minus 4x. Okay, so then I have plus 3y minus 7y. Combine like terms, that gives me minus 4y. And then what I want to do is add 53 to both sides. And so negative 13 plus 53 should be 40. Okay. Okay, so this is the second equation right here now. Now, can I simplify this any further? Well, here I have negative 4, and then negative 4 here, and then I have 40. So you can divide every single term by 4 to simplify this. But notice, what if we divide by negative 4? Let's give that a try. So negative 4 divided by negative 4, that becomes 1, and all we have here is x. Negative 4 divided by negative 4 again basically becomes positive 1. So we have plus y. And then we have 40 divided by negative 4, which is negative 10. So if we just divided by 4, we would have negative x minus y equals 10. We want to make the variables positive, so that's why we divided by negative 4. Okay, so this is now my new second equation right here. Alright, so what I want to do is I want to solve for y. So I solved for z in the first equation. In the second equation, I want to solve for y. So substitute z from the first equation into the second equation. Step 3, once I do that, then simplify. So, and simplify. I want to solve for y in the second equation. Okay, so I can do that pretty easily. I can go ahead and subtract x from both sides, and what that gives me is y equals negative 10 minus x. Here is my second equation. Here is my first equation. So I just want to save those for later. So I'm just going to put those in my pocket, speaking figuratively. So I have equation 1 and equation 2 inside my pocket. I'm going to save those for later. Alright, step 3 is done. Basically that. Step 4. We're going to substitute y and z into the third equation and solve for x. That's what we want to do. So here is my third equation right here. 6x plus 3y plus z. 6x plus 3y plus z is equal to negative 15, 45, not 15, negative 45. Alright. So I have what y is equal to and I have what z is equal to. Now, do I want to go ahead and substitute them all at once? That's going to give me a pretty long equation. So maybe I just want to do this one at a time. So the first thing I'm going to do is substitute in y. So what I'm going to have is 6x. Well, let me use the same color here. 45. I'm going to have 6x plus 3. Now notice here, I'm multiplying the 3 times the y. So what I need to do is put y in parentheses, and then just, since y is equal to negative 10x minus negative 10 minus x, I can kind of put that in there. And then I'm going to write the rest of the equation 3 is equal to negative 45. Okay, so now what I can do is I can go ahead and simplify. So I have 6x. Now this 3 is in front of the parentheses, so I need to distribute. The reason I know why I need to distribute is because we replaced y and the 3 was multiplying y, so we need to distribute here. So 3 times negative 10 is negative 30, 3 times negative x is negative 3x, plus z equals negative 45. Okay, so now I combine like terms. I have 6x minus 3x, that gives me 3x. Let's go ahead and multitask here. I want to add this 30 to the other side, and so I have 3x plus z is equal to negative 15. Okay, so now we got rid of y. We substituted y already. Now we need to substitute in z. So going all the way to the top, z is equal to negative 53 minus 2x minus 7y. So 3x plus, so instead of writing z, I'm going to write minus 53 minus 2x minus 7y, minus 2x minus 7y. So notice here the z is by itself. It's not being multiplied by anything, so I don't need to distribute. Here the y was being multiplied by 3, so I did need to distribute, but not in this case. So here I can just go ahead and combine like terms. I don't really need that parentheses there, and I don't need that plus sign. Actually, I did forget to write the rest of the equation. So I had 3x plus z equals negative 15. Okay, so let's combine like terms. I have 3x minus 2x. That basically just becomes x. Here I have 53. I want to go ahead and multitask here, so I want to add 53 to both sides. and I have minus 7y. Look at that, we have another y equals 53 minus 15. I just want to go ahead and calculate that. So 15 plus 53, that gives me 38. Okay, so look at that. This y came out of nowhere. Well, actually it didn't, but what do we have to do with this y? So we need to substitute it again, and remember, y is equal to negative 10 minus x. Okay, so let's go ahead and do that. X minus 7. Notice this y is being multiplied by 7, negative 7 to be exact, so we have to put the y in parentheses, minus 10 minus x equals 38. Okay, so we do have to distribute this minus 7, so we have x, negative 7 times negative 10 is going to give me plus 70. Negative 7 times negative x gives me plus 7x equals 38. Okay, let's go ahead and combine like terms. I have x plus 7x, that gives me 8x. And let's go ahead and subtract 70 from both sides. And so that gives me 8x is equal to 38 minus 70. And that gives me negative 32. Alright, we're very close to solving for x here. And x is equal to negative 32 divided by 38 divided by 8. And that gives me negative 4. Okay, so we finally solved for x. Let's look at the steps that we followed here. We first solved for z, and then we had to substitute z into the second equation. Once we did that, we simplified and we solved for y. When we solved for y, we took y and z and substituted into the third equation, and we finally solved for x. So now what we need to do is we need to substitute x guess this is step 5. Substitute x into the second equation and solve for y. Okay, remember the second equation, we started with minus 2x plus 3y plus z, but we ended up changing it so that it is just y equals minus 10 minus x. So y equals minus 10 minus x. But we just figured out that x is equal to negative 4. So when I rewrite this equation, minus negative 4. So be very careful. Don't just put negative 10 minus 4. It's negative 10 minus negative 4. And so when you have consecutive negatives, they become positive. So what we get here is y is equal to negative 10 plus 4. These two negatives basically become positive. And so when we simplify here, that gives me negative 6. Y is equal to negative 6. Okay, and finally the last step is going to be substitute x and y into the first equation. So here is the first equation. We started with this right here for my first equation, but then we changed it to this. So z is equal to negative 53 minus 2x minus 7y. Minus 2x minus 7y. Alright. So z is equal to minus 53 minus 2 times negative 4. Yes, and then minus 7 times negative 6. So when I go ahead and multiply this out, it's going to give me minus 53 plus, because negative 2 times negative 4 gives me positive 8, and then negative 7 minus 6 gives me positive 42. So when I simplify this further, I get negative 53 plus 50. And so z is equal to negative 3. There we go. We just solved this system right here, 3 linear equations with 3 variables, and finally we can write our answer. Now remember, when we solved a system of 2 linear equations with 2 variables, our answer was written in the form of an ordered pair. So this is an ordered pair. Pair basically means 2. But since we have basically 3 things that we solve for, 3 variables, we need to write not an ordered pair, but an ordered triple. So x was negative 4, y was negative 6, and z was negative 3. So that is my ordered triple. This is how I write the final solution, where negative 4 is x, negative 6 is y, and z is negative 3. So that is substitution right there. This is it. Okay. Next, we have to do Gaussian elimination, which is basically just elimination. So let's figure this out. Okay, the first step. Now let's take a look at the first step from when we solve 2 systems. So what it says was to multiply the second equation by a factor to eliminate y, and add 1 and 2. Same thing we're going to do here. So for step 1, I'm going to, so here's my first equation, second, and third. So multiply the second equation by a factor to eliminate x and add equation 1 and equation 2. Okay, so let's figure out what does this look like. So here I have equation 1, x plus y minus z is equal to 4. And then equation 2 is negative 2x plus y plus 2z is equal to 6. Now, I want to eliminate x, so let's figure out what do I get when I add these two together. So 2x minus 2x actually gives me 0, which is what I wanted. So do I need to multiply by anything to eliminate x? No, it actually conveniently already has it set it up for us. So I can just go ahead and add these then. So let's go ahead and add these two equations. So I have 2x minus 2x, that gives me 0. Y plus y is 2y. Negative z plus 2x is going to, wait, 2z, that's supposed to be 2z right there. So negative z plus 2z is going to give me plus 1z, and then 4 plus 6 gives me 10. So here, don't need that 0. Here is my new second equation right there. Okay. Step 2. Multiply equation 3 by a factor to eliminate x and add 1 and equation 1 and equation 3. Okay, so we're using equation 1 again. 2x plus y minus z is equal to 4. And then equation 3 was x plus 2y plus z. X plus 2y plus z is equal to 11. Okay. So I want to eliminate x. When I add these together, it gives me 2x plus x, which is 3x. I want to get 0. So what do I need to multiply this x by in order to eliminate those? Well, again, I have a feeling that students are always going to be saying 0. So when I times 0 here, when I have 2x plus 0, that gives me 2x, not 0. So maybe what I want to do is multiply this by -2. Now, I'm not just multiplying this x by -2, I'm multiplying the whole equation. So let's see what we have. Again, I'm going to write the second equation here. The first equation, here's the first equation. Now, when I multiply everything by -2 in the second equation, I'm going to get -2x minus 4y minus 2z is equal to -22. Okay, let's go ahead and add this together. So what I get here is 0. Y minus 4y is -3y. Z minus 2z, -3z. And then 4 minus 22 is -18. So here is my new equation 3. But notice I can simplify this. Looking all the way back to here, notice here we divided everything by -4 in order to simplify it. That's what we're going to do here. But we're not going to divide by -4. Instead, we can divide everything by -3. Again, we want to divide by a negative to make everything positive. So -3 divided by -3 becomes 1 plus z, so -3 again over -3 becomes 1. And then we have -18 divided by -3, which is going to be 6. So here is my new third equation right there. So we have our third equation right there. We have the second equation right here. And so let's go ahead and write the system again. The whole system, we're going to rewrite it. And this is what it comes out to be. So we have 2x plus y minus z equals 4. So the first equation remained unchanged. The second equation is now 2y plus z equals 10. And the third equation is now y plus z equals 6. Here's my new system. Okay, we're ready for step 3. So notice here we multiplied the second equation by a factor to eliminate x, and we added 1 and 2. Step 2, we multiplied the third equation by a factor to eliminate x and added 1 and 3. So in step 3, we need to multiply equation 3 by a factor and to eliminate y and add equation 2 and equation 3. Okay, so let's write equation 1, equation 2 and 3. So we have 2y plus z is equal to 10, and then we have y plus z is equal to 6. Now when focusing on just the y's, if I add these together, 2y plus y gives me 3y. Is that what I'm looking for? No, I'm looking to get 0. So because we already have experience doing this, I know that I'm going to multiply by -2. But remember, I have to multiply the whole equation by -2. So what I get here, again, let me rewrite everything. 2y plus z equals 10. And now I'm going to have -2y minus 2z is equal to -12. So I basically multiplied -2 for everything in the third equation. Now we can go ahead and add together. So 2y minus 2y gives me 0. Z minus 2z gives me -z. And 10 minus 12 gives me -2. Well, look at that. We can go ahead and solve for z now. So in order to solve for z, I need to divide both sides by -1. -1, and so what that gives me is z is equal to 2. Done. We solved for z. Okay, so now the steps are familiar here. Remember in the very first example for elimination, once we solved for x, we basically substituted in x into the first equation, into the second equation actually, in order to find y. So something very similar is going to be happening here. I'm going to, since we solved for z, I'm going to substitute z into the second equation and solve for y. So my second equation is this right here. So 2y plus z equals 10. 2y plus z equals 10. And so we can replace z with 2. And so we can go ahead and do the math here. We subtract 2 from both sides. So we have 2y is equal to 8. Divide both sides by 2, and so y gives me 8 divided by 2, which is 4. So finally, the last step is to substitute z and y into the first equation and solve for x. So my very first equation, here it is, 2x plus y minus z is equal to 4. We go ahead and substitute in y as 4 and z is 2. Okay, let's go ahead and solve. 2x plus 4 minus 2, which is 2, equals 4. subtract 2 from both sides, so we have 2x is equal to 4 minus 2, which is 2. Divide both sides by 2, and so x equals 2 divided by 2, which is 1. Finally, we found our ordered triple. So my ordered triple is going to be 1, 4, and 2. 1, 4, and 2. There it is. Okay. So we learned Gaussian elimination, we learned substitution using a system of 3 equations with 3 variables. And what I had you do is now apply the skills that we just learned into a real world situation. So we talked about how to set this up in class 12 through 14, and that's what basically your homework was. Alright, thank you for watching.